Greetings and welcome to the Oracle Plsql channel, a series of video trainings on the Oracle Plsql language. My name is Stephen Feuerstein and I'm a Plsql developer just like you. This lesson is part of my series on best practices for writing SQL and Plsql statements. And the focus of this lesson is leveraging key features of Plsql when writing SQL. Quick reminders. Download the code and supporting documents from Plsql Obsession for this and my other lessons. Plsql Obsession is a portal of resources for Plsql developers at toadworld.com/sf. Click on the demo zip link to download all the files that I use in this and my other lessons. Click on training seminars and presentations to download the PowerPoints that support my various trainings, and check out the rest of the website for lots of other resources. In the context of this lesson and all the other lessons and best practices for writing SQL and Plsql, I strongly encourage you to check out Bryn Llewellyn's white paper called Doing SQL from Plsql, Best and Worst Practices. Bryn is the Plsql product manager for Oracle Plsql, and he knows the language better than anybody else in the world. So do check out his writings on Doing SQL from Plsql. It covers the topics in this lesson and much, much more. So best practices for writing SQL in Plsql, part 2. We'll take a look at using select into for single row fetches. How, when you're working with bulk collect, you should use the limit clause. How and why you should use the Forall statement for multi-row DML operations. And use collection and table operator for in clauses of indeterminate count. You need to do in, but you don't know how many elements you've got, and it could be an awful lot. So let's go into much greater detail on each of these. Use select into for single row fetches. Well, if you've been around Oracle for a long time, you might remember that a long time ago, like back in Oracle 6, gurus, experts like myself, warned against using select into, an implicit query, and instead recommended that you always use explicit cursors for single row fetches. And there was a rather arcane explanation about how when you do a select into, Oracle follows the ANSI standard, so it has to fetch once to fetch the row and fetch a second time to see if too many rows have been raised, so you always do two fetches with select into. But with an explicit cursor, you can just do a single fetch, and therefore explicit cursors are faster. Well, maybe that was true at some point in the distant past, but it's not true anymore. Oracle has optimized select intos so that in general they are faster than doing single row explicit cursor fetches. Now, it's true that in Oracle 11 the difference between the two is quite small. In Oracle 9 and even Oracle 10, you'll see much more of a difference, perhaps 20% faster to use select intos versus using explicits. But my feeling is that the most important recommendation here is not using select into versus explicit, but hide your query inside a function, so that if Oracle changes the picture again, if they say, well, starting in Oracle 13, explicit cursors are now faster than implicit, or they have an entirely new method for getting a single row, you will only have to adjust your code for that query in one place. So yes, today, Oracle 9, Oracle 10, Oracle 11, use select intos for single row fetches, but put that single row fetch inside a function and call the function instead. Let's take a look at some examples. So, first of all, just to be clear about the difference between an explicit versus an implicit cursor, here's a package called explicit implicit, and I have within it a function called implicit. And implicit has a select statement in it, select into. That means that Oracle will implicitly open the select statement, fetch the single row, and close it. And it will raise no data found if no rows are found for this, for example, numeric value, or it'll raise too many rows if more than one row is found. So this is a single row fetch with a select into an implicit query. And here's an explicit query. So I declare a cursor, I open, I fetch, I close, and then I return. So this is the approach that we recommended years and years ago. Was faster and better than using this. That is no longer the case, and whenever you're doing a single select, always do a select into, and then retrieve the value and check for no data found or too many rows as your application requirements suggest as necessary. Now let's talk further about this last point, hide your query inside a function. This topic is covered in a lot more detail in Say Goodbye to Hard Coding, and specifically Stop Writing So Much SQL. But I want to give you a basic idea of the point here. Here's an application procedure called Do Stuff with Employee, and it's a high-level application program responding to user requirements. I pass the employee ID, and then I have to do some stuff with the employee. And first, I'll get all the information about that employee and put it into a local record. So there's my single row fetch. I do a select into, so this is faster than an explicit fetch. But the problem is that I'll see the same select statement over and over and over again throughout my application. Not a good idea. There are several reasons why it might not be a good idea. For example, if I ever have to change the select statement, I have to go back and change every single place where the select statement is written. It makes it very hard to manage and also hard to optimize the code. What if Oracle comes up with a better way to do things? How easily can I adjust my code? So my approach is to not write select statements, select intos over and over again in my application. Instead, I will write or generate a function called oneRow inside a package, my query package for employees. And this oneRow function does exactly the same thing you see here. It just looks up the data for that one row of employee information, like this. Pass the employee ID, look up the information, and return it. So rather than write the select statement over and over again, simply call the function to do the work for you. So one function called 100 times versus the select statement written 100 times. Both of them use select into. And the reason this hiding process is so valuable is that when Oracle comes up with new approaches, you can take advantage of it so easily. So now that I've got my function oneRow sitting inside my package, when I upgrade, for example, to 11G, I can take advantage of a fantastic new feature called the result cache. It allows me to cache data that's being queried, greatly improves performance of my functions, and all I have to do is add a single keyword to my function. And all the programs that call this function, like this one, do not have to be changed at all. They simply get a lot faster. So hide your select statements, especially your single row queries, inside functions, call the function, and you and the rest of your application team and your users will be thanking yourselves in the years to come. Next, always bulk collect with a limit clause. Well, actually, first of all, always use bulk collect to retrieve multiple rows of data. Bulk collect is a feature that will greatly improve performance of querying of data. So if you're retrieving multiple rows, not just one row at a time, use bulk collect. Note, however, that read-only cursor for loops, if I'm doing a loop that has a select statement at its foundation, and it doesn't do any DML inside of it, it's a read-only cursor for loop, you do not have to explicitly convert to bulk collect. Oracle will do it for you as part of its automatic optimization. And check out my effective management of Plsql applications, and specifically the optimizing compiler, for more details about that. So you don't have to explicitly convert those. But in general, if you do find a loop that is reading data, you should switch to bulk collect. And when you do that, when you use bulk collect, you should almost always use the limit clause with that bulk collect statement to avoid possible memory errors associated with an unlimited bulk collect. Now, I cover this topic also much more thoroughly in my bulk processing in Plsql, in which I talk about bulk collect in detail and also the Forall statement. But for a quick refresher here, let's take a look at some files. Now here's an example of using a select bulk collect. So I say get all the rows of data from my employees table, drop it into a collection that looks just like the employees table. So this nested table type mimics my employees table. And in a single select statement, I can grab all the data from that employees table, drop it into my collection, and then process the contents of that collection. Very nice, simple code. The problem is that if the employees table gets bigger and bigger, my program will consume more and more process global area memory to populate my collection. And I might at some point start to get memory errors. So what you should do in these kinds of situations is use the limit clause. So move my select statement into a cursor. Now I'm talking about moving away from an implicit cursor to an explicit, but that's because it's multiple rows. So instead of a single select into, I declare my cursor, I declare my collection based on that cursor or table, and then I open the cursor, and inside a loop, I fetch bulk collect into. So I take advantage of bulk collect for improved performance, but I specify an upper limit on the number of rows that can be fetched with each single fetch from the database. So this is saying I can only afford memory for up to 100 rows at a time. So get me 100 instead of 1, or instead of 10,000. It gets a certain batch of rows at a time. And you'll find that even if you set the limit to 100 or a couple of hundred, and you're fetching through thousands of rows of data, the performance will still be excellent, much better than doing a non-bulk collect fetch. And you can again find out much more about it in my bulk processing in Plsql section. Always use Forall for multi-row DML. So Forall is the other bulk processing feature of Plsql, and it has to do with pushing data back to the database. And essentially, you should take every loop, every single loop you can find in your programs that contain DML statements, and convert them into Forall statements, and the boost in performance will be just incredible. It is the single most important enhancement you can do to your programs to improve performance of SQL statements inside Plsql. However, the conversion process can be tricky and complicated. Again, check out the bulk processing on Plsql series, and specifically the lesson on Forall, for many more details about using the Forall statement. But just to give you a couple of quick examples. The Forall statement again uses collections. So if you don't know what collections are, if you're not used to nested tables and associative arrays and v-arrays, you should also go through my extensive series of video lessons on collections. What I'm doing in this program is comparing the performance of doing row by row inserts. Here's a for loop with an insert statement, and comparing that to the performance of a Forall statement that has an insert statement inside of it. So instead of a for loop, I have a Forall statement, though other than that it looks pretty much the same. And simply by making this one change in syntax from a loop to the Forall statement, I found the following performance benefits on Oracle 11. A for loop of 100,000 row inserts took almost 4 seconds, 3.8 seconds. The Forall statement, 100,000 rows of data inserted in 0.09. It's just amazing. And all I did was change the approach I took from my single row fetching to my Forall fetching. Sorry, my Forall inserting versus my single row inserting. Now the Forall statement is a very complicated one with many different aspects and sub-features. For example, you save exceptions or log errors to allow you to continue past exceptions, using the indices of clause and the values of clause to work with sparse collections, collections that have gaps within them. But the main thing to understand is that whenever you see a for loop with DML statements inside of it, you need to think about converting them. In other words, whenever you see code that looks like this, it's a prime candidate for conversion. So I've got a cursor for loop, and within that I have one or more DML statements. Now Oracle will automatically optimize the performance of my cursor for loop to work like a bulk collect. However, it will not automatically optimize inserts and updates into Forall statements. It can't guarantee the lack of side effects. So you have to explicitly convert the inserts and the updates into Forall statements, which means you have to convert the for loop into a bulk collect to populate the collections that drive the Forall statements. Again, check out the bulk processing in Plsql series for all the details, but the main thing is to look for scenarios like this and then do the conversion to bulk collect in Forall, and your performance will improve dramatically. Finally, use collection and table operator for in clauses of indeterminate count. So as you're probably familiar, you can have an in clause in your SQL statement, and I can say, is my element, my column value in a comma delimited list of elements? Unfortunately, Oracle has a maximum of 1,000 elements that are supported in a comma delimited list. And you may have more than that number of elements, and also you may not know in advance how many elements you've got, or even if you have an in clause requiring dynamic SQL. And there are lots of actually different approaches to take here. We can use dynamic SQL. We can use an in clause with a table operator. We can even use a member of syntax with nested tables in Oracle 10. And the bottom line is that if you have the situation, you have an in clause with a lot of variability, the number of elements could pass 1,000, then the best approach to take is to use a collection with a table operator, giving you the most flexibility and the most performance. Let's take a look. So you'll find a number of files that start with in clause. This is a series of programs I put together to test different approaches to doing in clauses. You can run the in clause setup script first to construct a table, populate it with some data, and so on, create some collections to support it as well. And then I created a package that runs through a variety of the scenarios. So I can use a native dynamic SQL list, I can use bulk collect, bulk processing, DBMS SQL, nested tables, member of, etc. So each of these different programs use a different approach and then show you the implementations in the package body. So here, for example, is the idea of using a dynamic in list. I can simply put my list, my comma delimited list, in my dynamic SQL statement with the in clause. So that gives you a lot of flexibility, but you're still limited to 1,000 elements. And a different approach I can take is to use my nested table list. So instead of having a list of elements in a comma delimited format, I create a list of elements in a collection. So pkynt is my list of integers, my primary keys. So this defines a nested table type at the schema level. Now, if you don't know what a nested table is, if you haven't worked yet with collections, you should learn, go through that series of videos on collections. But this allows me to store a list of numbers. And then I can pass that list of numbers into my program. And in my select statement, I can select from my table where ID is in, and instead of providing a comma delimited list, I say select is in a select from another table or view, which you can do in SQL. But in this case, my table or view is actually my list of integers, my nested table. And I can put that inside a table operator and select from it, select column value, which is the hard-coded column name for my pseudo table. The table operator converts my collection format into my relational table format. I select from it. I ask, is the ID in that list? Very succinct syntax, very simple to understand, very simple to maintain, and very fast. Another approach you could take, I'm not going to go through every single variation here. I'm going to show you the most important. You can explore each of them on your own time. The other approach you can take is taking advantage of new syntax in Oracle 10, which is member of. You can simply say where ID is a member of the list. That's even simpler than using the table format and the in clause. The problem with member of is that inside SQL, the performance is quite bad. So while it's very simple to write, it's not something you're going to want to use in a production application, at least until Oracle 12. The performance still looks bad in Oracle 11. You might want to check again in Oracle 12. The syntax is very performant, high performing inside PLSQL. In other words, I can use member of with a Plsql collection in my code. But inside an SQL statement, member of is a killer. It simply takes too long. Let's see if I've got some results in here. Okay, so the rest of this package shows you, or it gives you the drivers to run your different tests. Let's see if I can find an example that shows some of my results. I thought I had them here somewhere. Okay, so on 10.2, here's the kind of results I got. A native dynamic SQL list, 29/100ths of a second. That's with a simple concatenation of my in clause. That was quite fast, 29/100ths of a second. Notice my nested table list, 34/100ths of a second. So also very fast. And the key thing here is that while it's a little bit slower than doing my quick native dynamic SQL concatenation, it is not limited to 1,000. I can have as many elements, I can have as many elements as I want in my in clause when I select from a table. So using my nested table with a table clause is very fast and has no limitations. But notice the member of timing was terrible. Very, very slow. There's a bug there for sure. So the bottom line is that if you're using small lists of information, small comma delimited lists, sure, go with your in clause, whether it's dynamic or static. But for the best general purpose solution, regardless of how many elements you have in your list, you will find that this approach is the simplest and the fastest and the most flexible. Avoid implicit conversions. So in general, Oracle is very forgiving. It will implicitly convert a string to a number, a date to a string, and all sorts of different kinds of conversions, and it won't complain. It won't even tell you it's doing it. However, implicit conversions have a price. First of all, depending on the way that Oracle does the implicit conversion, and you don't get to decide that, it can affect the optimization of SQL statements. It might turn off the use of an index because it converted an integer to a string, whereas you thought it might have been converting a string to an integer. There's also overhead to the conversion that is best avoided. In other words, don't do implicit conversions if you can either do them explicitly or you can use the correct data types to avoid the implicit conversion. Quick example of the performance impact. In my explicit versus implicit, I showed you this earlier. We have the select into and the cursor with an open fetch close. Here's an explicit that contains a conversion. I'm doing a to-car. I'm doing it explicitly just to show you the cost of doing a conversion, but Oracle might do these implicitly in your code if you're not careful. And notice, with conversion, my elapsed time jumped to over 7 seconds, where both of my implicit and explicits were actually under 7 seconds. So it looked like it was about 3/4 of a second performance penalty in this particular test. So avoid conversions whenever possible and use explicit conversions rather than implicit so you control the conversion process and you're exactly sure what's going on in your code. So to sum up, best practices for writing SQL and PLSQL. The most important thing is to stop taking SQL for granted. Don't write it wherever and whenever you want to. Hide your SQL statements behind an API, a set of programs that retrieve and change the data for you. Make sure your schemas, the user schemas, can never directly touch those tables. Fully utilize the SQL language. If you can do it in SQL, don't complicate matters with PLSQL. Make sure that you learn about the new features of the SQL language in 10 and 11. Take advantage of those analytical functions, with clauses, flashback queries, and so on. Avoid repetition of SQL. Hide those queries inside functions. Get ready for the function result cache feature of 11G. Stop writing so much SQL. And take advantage of collections for flexibility and performance. Make sure you're leveraging Forall and bulk collect for all of your repetitive SQL executions. And you get great in-clause flexibility by using collections with the table operator. Next steps. Download that demo zip if you haven't already done so from toadworld.com/sf. Run the samples, try them out, check out the in-clause package, and look at all those different variations, explore them in detail. Make sure you understand the pluses and minuses of each one. But again, you're most likely going to be using that collection with table clauses. And then watch all the lessons referenced in this one for complete details on utilizing SQL effectively in your PLSQL programs. So this lesson in many ways offered a guide to some other critical lessons around collections, Forall and bulk collect. So use this as a starting point. Make sure you cover those other lessons for all the details. Thanks for joining me, and happy PLSQL coding.